Hi, this is Mr. Manley. In this video, I just want to talk a little bit about polynomial functions, just to give them a little bit of a context based upon what you know about functions already, or some functions that you know. You know a lot of polynomial functions already. You know a linear function, and this is going to be a function that can be represented with an equation y equals, and then it's going to be something in terms of x. Okay, of course, we're never going to have a function that is written precisely like this. This is just my notation to indicate that this is some expression that has an x in it, x to the first precisely. And then you also know about a function that looks like this, a quadratic function, and that's going to be a function that can be written, and there's going to be something in terms of x squared. And then this one you might not be as familiar with, but a function that looks like this, and that is something in terms of y equals x cubed. And then if I just go one step further here, get of a function that looks like this. You probably haven't seen this before, and this would be a function that can be written as an expression that has x to the fourth somewhere in the expression. And these are all polynomial functions. Now compare those to some other functions that you're familiar with. For instance, a function that looks like this would be something in terms of just very generally something like this. It's going to involve 1 over x. And really specifically, I mean, what is involved here is that there is going to be a variable in the denominator. And this would not be a polynomial function, but it would be a part of a bigger group of functions that polynomials are a part of, which would be an algebraic function. Another function of this nature would be the radical function. So if I took the radical function that looks like this, and that's y equals, and it's something with a radical and a variable, and that would be a radical function. That's also an algebraic function. So this is we have this broad category of functions: algebraic functions, polynomial functions, and let me just look at a couple of others that we could see. We can see something that we will look at actually in a pre-calculus class would be a transcendental function, and one of the transcendental functions that we encounter looks like this, and that would be an exponential function, 2 to the x. That's the parent function there. And again, we could have all sorts of variations on that where we have a variable exponent. That's what's going to make it an exponential function. And then another function that is in a similar category here, in this transcendental function category, would be a function that looks like this. Oops. Here. All right, so a function that looks like that. And that's going to be some kind of log function, some kind of logarithmic function. These are transcendental functions. And then a final category of function that we look at in pre-calculus would be a trigonometric function. And just one example of a trigonometric function would be a sine wave, a function that graphs like that. So the categories of function that I'm looking at here are trigonometric, transcendental, and algebraic, and polynomial functions. Just briefly using polynomial functions as a point from which to operate in the discussion here, think what we would consider any function is going to exist in order to capture some pattern, some sort of information, some sort of data that we collect, or some sort of information about the world we collect. And if that information lies in somewhat of a straight line, then we say that that function may have that may be a relationship that can be captured by a linear function. And then if I have some sort of data that drops and then rises, that may be algebraic. And so on. The data that we collect, if we're collecting data, it may look like it fits some sort of pattern that could be captured by a particular type of function. Another element of a polynomial function that we would consider is that it is written in the form, the polynomial function can be written in the form, say, ax to the n plus bx to the n minus 1 plus cx to the n minus 2 plus dx to the n minus 3, and so on. And then all the way down to some constant, which I'll say z, some constant where there's no more variable. So this would be a way of identifying a polynomial function. We can see the shapes, again, that we are looking at. So we know the line, and we know the parabola, and then this curve shape and that shape. And then we could continue with that, and you may kind of get the idea just visually what the function looks like if I just continued here and said, oh, and then here is another one, and here is another one. And you get the idea, you hopefully have a general idea about what a polynomial function looks like, as opposed to, say, these algebraic functions. And you could look at those and say, yeah, that's not a polynomial function. You could look at this trigonometric function and say, yes, that is not a polynomial function. So hopefully, after this video, you have an idea about what a polynomial function is and what a polynomial function is not, and have some appreciation for the algebraic elements of a function, of a polynomial function. So that is, what would the equation look like, and some appreciation for the graphic element of a polynomial function as well.